So we're going to be talking about what we call uncertainty of the mean. So uncertainty still means the same thing. It's how far from a measured value we expect to find any other values done the same way. But when we talk about uncertainty of the mean, we are talking about experiments that we run multiple times and then find the average. So our measured value is now going to be our average measured value. How do we find an average? Just a plain old mean or average. Good. So we add all of our measured values together and divide by however many measured values we have. And the way we're going to report the uncertainty is half of the range. So when I talk about a set of data, what is a range? What does range mean? Biggest to smallest. So your range is your biggest value minus your smallest value. And then we're going to divide that in half. So that will be our uncertainty. And then still put our unit at the end. So when we report averages with uncertainty, it's going to look the same as how we reported uncertainty with measurement tools for single measurements. It's just a different way to figure out the uncertainty. So I'm going to scroll up. The next part is very, very detailed steps for finding and reporting the uncertainty of the mean. So an average value with uncertainty of the mean. It is very, very wordy. We're going to talk about it, but I'm going to give you a few minutes to write it down, and then we'll talk about it. This is very wordy. So think about what we just talked about. Average value plus or minus half of range followed by the unit. And you'll see just how wordy this is. But for those of you who enjoy having more details, this will be helpful, especially when you go back and look at these notes in a few months, maybe after you've gotten out of the practice of reporting uncertainty, you'll probably appreciate having more details rather than less. So, first thing you're going to do is, for your set of measured values, find the average. So how do we say we did that? Add the values together and divide by how many values you have. And then, for that measured value, for the average, you're going to round to the correct number of significant figures. So however many significant figures there were in your measured values, you'll round the average to that number of significant figures. Okay? Then, to find the uncertainty of the mean, you're going to take your range, right? So biggest value minus smallest value, and divide it by what? 2. So it's half of the range. Remember, at the very beginning of uncertainty, there were 2 rules we talked about with uncertainty. We said uncertainty values should have only one non-zero digit. Yes? And that uncertainty digit should be in the last significant figure for your measured value you're reporting. So those 2 rules, when we're finding uncertainty of the mean, that's where we really have to make sure we're following those. So, find the uncertainty, one non-zero digit in the uncertainty. So now you need to compare your measured value, your average measured value, and your uncertainty, and make sure that the number place where your uncertainty is in the same place, the same digit, as your last significant figure in your average value. We're going to look at all kinds of examples to make that clear, okay? This is just a lot of words for it. And then you're going to report your average with uncertainty, just like we did before. Measured value plus or minus uncertainty followed by the unit, okay? So let's look at some examples. So I'm going to give you a minute or two to write all of these examples down. I would leave a little bit of space between them. So for these examples, we're going to look at what's reported and say, is it reported correctly or is it not reported correctly? And if it's not reported correctly, we're going to correct it as best we can, okay? So I would leave a line or at least some space next to each of these so you can correct them if needed, okay? Okay, so let's look at these examples together. We're going to talk about each of them, so if you didn't get them all written down, you can write them down as we go over them. So remember, we're looking for two things. One, the uncertainty has one non-zero digit. Another way to say that is it has one significant digit, right? And that wherever my uncertainty is, what digit or place my uncertainty is, that one non-zero digit, needs to be in the last significant digit of my measured value. So if we look at the first one, is my uncertainty one non-zero digit? Yes. It's 0.004. So that 4 is the only significant digit, one non-zero digit, one significant digit. Same thing, right? In this case. And then is that one digit of my uncertainty in the same place as my last significant digit? Yes. So if those two things check out, then I have at least reported it correctly. So for this one, I would say, yes, it is reported correctly. Okay, the second one. Does my uncertainty have one non-zero digit? Yes. Is that one digit in the same digit or place as the last significant digit of my uncertainty? Yes. So is this reported correctly? Yes. Okay, the next one. 25,000 plus or minus 2,000 gallons. My uncertainty, is there one significant digit? Yes. The 2 in the thousands place, right? And is that 2, that one significant digit in my uncertainty, in the same place as the last significant digit in my measured value? Yes, right? The 5 is my last significant digit in the measured value. So is this one reported correctly? Okay, what about the next one? Is my uncertainty only one digit? No, it's got 2 digits. So what do I need to do? I need to round it to what? 0.04. And then now, is that 0.04 the 4 in the last significant digit of my measured value? Yes. It's in the same place as this 0. So I would report this as 156.00 plus or minus 0.04 Kelvin. Does that make sense? Yes? Okay, what about the next one? Does my uncertainty have one significant digit? Yes. Is that one significant digit in the last significant digit of my measured value? No. So here, something went wrong. Something went wrong, but just us looking at this problem, we don't know where it went wrong, right? It could be that the person reporting the measurements didn't report the measured value with the correct significant figures, or they didn't know how to report uncertainty. So, the best we can do, we can't make up significant figures, right? All we can say is, based on that 4,000, it looks like the number has 2 significant figures, right? So, any idea what we might do? Okay, so let me write this out. My last significant digit is in the hundreds place, right? So 2 gallons doesn't make sense. I can't read the ones place, right? Can I read the tens place? No. Can I read the hundreds place? Yes. So what I'm going to write it as is 100. I had to round up until I got to that last significant digit. Okay, this next one got 2 problems, right? My uncertainty has 2 non-zero digits. So how would I round 31 to have only 1 significant digit? 30. So if I have to round that to 30, then can I actually report the ones place in my measured value? No. My uncertainty is bigger than the ones place. So I can't, within reason, report that value. So how am I going to report this number, this average number of people? 3,460. Now, does my uncertainty have one non-zero digit? Is it in the same place as my last significant figure? And in this one, you had to work on both the uncertainty and the measured value, right? To make them correct. What about the next one? 7.1 plus or minus 0.002 grams. Is my uncertainty one non-zero digit? Yes. Is it in the same place as my last significant digit? No. I can only measure to the tenths place. So I need to report my uncertainty there. This is a really good scenario to be in, where you are doing an experiment multiple times, you find the average, and your uncertainty for that average is smaller than the uncertainty associated with the measuring tool, right? Your values were very, very, very close together. That's a good thing. But we still can't report the uncertainty as smaller than we could measure. So any idea how we might report this? 7.1 plus or minus, you're going to just have to round that uncertainty up to what? 0.1. And this is an experiment. If I got that small of an uncertainty, I would try to find a balance that measured more digits. Because then, if it measured to the hundredths place, or the hundredths place or thousandths place, then you are actually measuring those values in that place, and so you'll have more significant figures. And then the last one. Do I have one non-zero digit in my uncertainty? Yes. Is it in the same place as my last significant digit? No. So what am I going to have to do? Who am I going to have to round? The average value, right? So I'm going to round it to what? 46, good. Plus or minus 2 liters. So this example that we just looked at is one where you did a measurement multiple times, and your uncertainty, so half of your range, was bigger than the uncertainty associated with the tool that you used. So your data is limited by how far apart your measured values were. So we would say, in that case, if our measured values are far apart, would we say that our data is precise or not precise? Not precise. Okay, so the reason why we did this is because those two rules, they sound easy, right? One non-zero digit in the last place as our last significant digit in the measured value. They sound easy, but you really need to see them in practice to understand the different scenarios where you might have to round, okay? So now we are going to look at some data. I'm going to cover it up because the answer is already there. The answers are already there. What I want you guys to do for me is write down, these are two different sets of data. How many trials do we have? 6, and we found temperature. So take a second and write these down, and then we're going to go through and find the average. We're going to find the uncertainty, and then we're going to make sure that our average measured value and our uncertainty match up and write our overall answer, okay? So I'm going to give you a minute or two. So that's rounded with the correct number of significant figures because there's 3 significant figures in all of my measured values, so my average should have the same. So then to find the uncertainty, we need to find the range. So what's my biggest value? 21.3, and my smallest? 21.1. So we're going to find the difference, so subtract, and then divide by what? 2. So when we do that, we get the range is 0.2, and then half of that is what? 0.1. And then our unit at the end. So then we need to do our double check. Does the uncertainty have one non-zero digit? Yes. Is it in the same place as the last significant digit of my measured value? Yes. So I've got my answer. Average value plus or minus uncertainty, unit at the end. Okay? Let's look at the next one. So the next one, when you find the average, what'd you guys get? What did you get? 120.4? That's bigger than all of the measured values. You should get 21.
Oh, wait, and then I forgot to
Oh, 120, yeah. You should get 21.4. Yep. And then we got to figure out our range. So what's our biggest measured value? 22.1. So 22.1 minus, what's our smallest? 20.7. And then divide by 2. And what do we get for the range? Or the uncertainty? 7. And then our unit at the end. So does our uncertainty have one significant digit? Yes. Is it in the same place as our last significant digit? Yes. Good. Okay. So below, there are student examples. So I want you guys working on those. And then